Hello dear students, I'm here letting you understand number 2 and 3 of exercise 11.3 of the algebraic expression. So here I start with the number 8. So very easy question, alright. So in this number 2a, what do we have? See, a plus b whole cube we have to divide by a plus b. Okay. So a plus b whole cube, this we have to divide it by a plus b. Okay. And now we can use here the rule of the dividing with the terms having same base. Like so, here we can consider these both a plus b as the same base. So we see here a plus b below, by which is getting divided, and its power we consider as 1. So the thing is, what if two terms getting divided with the same base, then their power should get subtracted. Okay? So x power m minus n we can get. So same thing we can do here. Okay? So a plus b whole power 3 minus 1 you can do. So this we can get a plus b whole square, and that is the answer for it. Okay? So it's of a number, and now similarly you can do number b. So in the b number we have 2x minus by whole power 5, which is getting divided by 2ax minus by whole power 2 or square. Good. Now here happens same thing. So we see the same base and their powers are different, 5 and 2, and we can get subtracted. Good. So we get there 2ax minus by whole power 5 minus 2. So this is going to give you 2ax minus by whole power 3. So that's the final answer for it. And I go with the number C, A and B of them, and I wrote this. Okay, so I raise the A number. Now I'm going with number C. Right? So you're saying 3a minus b plus c whole power 5. That is getting divided by here 3a minus b plus c whole power 4. Is it 3a minus b plus c whole power 4? So as these are getting divided, it is very same. You have to subtract the powers. So 3a minus b plus c whole power 5 minus 4 you can get, and it will give you 3a minus b plus c power 1, and 1 is not written. This simply we write 3a minus b plus c. So this way we can do number C. And same like we go for number D. Now before I do number D, I like to let you know about one rule. Right? So here, right? So suppose there 5 divided by 5. We already know. Already it is 1, isn't it? If some number you get divided by the same number, its result is 1. And now this is going to give you one formula of the division. Like what is that? See, so 5 power 5, that means 5 power 1 above also and below also, is it? So as a rule of division, we can get 5 power 1 minus 1 subtracted. So it's going to give you 5 power 0, and we already know its value is 1. So it means what? 5 power 0 is value is 1. So what we can generalize here is, for any base, if its power is 0, then we can make choice of its value as 1, or we can say its value is 1. So it happens for any variable or any expression, is it, or any numerical quotient or any real number. Like so suppose there is variable x, right? So if variable x is 0 and its power is variable x and its power is 0, then its value is 1. And same like there are some value 7 power 0, so its value is 1, or some expression is there, x plus y minus z whole power 0, so its value is 1. So for any real value or any expression, is it, if its power is 0, then its value is 1. So that we are going to use here in number D. So in number D we do have here 4xy minus 3z plus 1 whole power 3, that we are getting divided by here 4xy minus 3z plus 1 whole power 3. And now you get what you way. Okay, I will this first. Okay, so I will the previous number. Now here what we are going to get, 4xy minus 3z plus 1 power 3 minus 2. Is it? So good. As they are getting divided, their power will get subtracted. So you get there 4xy minus 3z plus 1 power 0. Is it? And as we have already stated, for any expression, if its power is 0, then its value is equal to 1. So its answer is 1. So for number, this 2 number D we did it, and now I go with the number 3. So first I go with 3 number 8, and for that I'll go with this number. Okay. So number now 3. So 3 number, first I do here A. So here is clearly visible that one binomial expression is here, which is getting divided by this. Is it? So we rewrite as the form keeping divide line. So 3x square y power 4 plus 6x cube y square and z cube. Is it? So this getting divided by here 3x square y and z square. Is it? And now what we can do here is we can separate the base. Like suppose there is a plus b by 2, it can be separated and can be written as a by 2 plus b by 2. So same thing we do here. Like so you see here two terms. Is it? This first term and this another term second. Is it? And this is getting added and is getting divided by some of these two terms is getting divided by here one monomial. So what we do here is we can separate the base. Like so let's separate it. 3x square y power 4 z power 5, and it will get divided by 3x square, is it, and y and z square, and plus is there 6x cube y square z cube, and that we get divided by 3x square y and z square. And now what we do next is we apply here rules of division. So first we can cancel here 3, this cancel, and of the x square, so these x square are same, so they also will be cancelled, or you may apply the rule as we just stated before. So I cancel directly. And now for y power 4 and y power 1, so as they are getting divided, the powers will get subtracted. And so we do same for the z power 5 by z square, so their powers will get subtracted. Now same we do for the second one. So by 3 the 6 can be cancelled for 2 times, the very first thing, and after that, sorry, it's 2. And of the x, these are having the same base but different powers, so their powers will get subtracted, so minus 2. And for y also the same, they are getting divided, so their powers will get subtracted. And here you below can consider as a power 1, so we get there y power 2 minus 1. And same like for z, so z power 3 minus 2. So once you do that, you get there y power 3, z power 3 plus 2x power 1 you need to write, y power 1 you need to write, and z power 1 you need to write. So you get there y cube, z cube, and plus 2xyz as the result for this number A. Now I go with number B. So I read this first. Now I'm going with number B. So here in B, 12a power 7, b power minus 4, c power 4 minus 18a square, b power 2, c power 3 is getting divided by 6a square, b and c power minus 2. So what you have to do here is same thing. We have to separate the base first. So 12a power 7, b power minus 4, c power 4. We get separated the base, and we write here 6a square b into c power minus 2, and same we do for second term 18a square b square c cube and that will get divided by here 6a square b into c power minus 2. Another thing is what, by let's go for a number first. 6 by 6 you can cancel 12 for 2 times. First thing is that. And now for uh, a power 7 and a power 2 we do have, so it will be definitely subtracted, but I'm seeing here negative power, so let's deal with that first, right? So a power 7 divided by a power 2. I'm not doing anything for this first. So at first I'm turning negative power into the positive power. So you see here b power negative in numerator, is it? So you have to turn it into positive by bringing it down or bringing it into the denominator. But b you see already there in denominator, is it? This b you see already in the denominator. Same we copy, and b power minus 4 which you see above in numerator, let's bring it down in the denominator to turn it into the positive power. So b power 4 you make by bringing down into the denominator, and it turns into the positive. And now let's go for c power 4, that is c in the numerator which is already positive, so let's do nothing for that. And c power minus 2 which is c in the denominator, is it? You need to turn it into positive by bringing above in the numerator. So what you do here is c power 2 will bring it in the numerator and it turns to the positive. So making positive all done for the first term. Now we go with the same thing for the next term or second term. So first is by 6 you can cut 18 for 3 times, that you do. And after that you can cancel here a square, both are a square, so you can cancel. And then b square by b, either you do right now or you do later, one matter. So I'm not doing right now, so it's copying same first. I'm changing negative power into positive first. So c power 3 above you see, let's copy it, same in the numerator. And which you see c power negative, which you see below over here, or in denominator c, is it? So this you need to turn into positive by bringing it into numerator. So c power 2 you bring above in the numerator and it turns positive. So after doing this step, now we apply to it. Like so, about here a power 7 and a power 2, they're getting divided, is it? So their powers we get subtracted by bringing above. And after that c, so here c, these two are on the same numerator, is it? So it means they are getting multiplied, and we have the rule what, if two terms are getting multiplied, their powers we have to add. So c power 4 and c power 2, is it? Their powers we have to get added. And same thing we have to do down, because they are also getting multiplied down, like so b they are getting multiplied. Okay, so b power, so this you consider as the power 1, no power mean 1 power is there, so b power 1 plus 4 we need to do, and 3 same. And here these two terms b square and b, they are getting divided. So b below which b you see it is power 1 you can consider, so we have to subtract here. So 3 into b power 2 minus 1. And about c cube and c square, they are getting multiplied. So as they are getting multiplied, their powers we have to add. C power 3 to get, and this way we get there the result 2a power 5 c power 6 and divided by below b power 5, and then minus 3 b power 2 minus 1 is 1, we need to write 1, and c power 5. So this way we get the answer of 3b also. So in this video I made you learn of number 2 from A to D and 3 number A, B. So we will catch up in the next video. What do you understand?